Imagine everything in the universe packed into a tiny space smaller than a pinhead. This was the state of the universe about 13.8 billion years ago. Suddenly this tiny space exploded with unimaginable force. That explosion is what we call the Big Bang. The Big Bang wasn't like an explosion we see on Earth. It wasn't something happening in space. It was the expansion of space itself. Everything in the universe, all matter and energy, came from this initial explosion. In the first fractions of a second after the Big Bang, the universe was incredibly hot and dense. As it expanded, it cooled down, and tiny particles started to form. These particles would eventually become the building blocks of everything we see in the universe today. The universe, in its early stages, was filled with tiny particles like protons, neutrons, and electrons. These particles were moving very fast because of the intense heat. As the universe cooled, these particles slowed down and started to come together. Protons and neutrons combined to form the nuclei of atoms. Electrons, much smaller than protons and neutrons, began to orbit these nuclei, attracted by the opposite electric charges. This is how the first atoms, like hydrogen and helium, were formed. Gravity, the force that pulls things together, started to pull these atoms together into giant clouds of gas. These clouds became denser and hotter over millions of years. Eventually, the pressure and heat at the center of these clouds became so intense that nuclear fusion began, igniting the first stars. Stars didn't form in isolation. Gravity pulled them together into vast collections called galaxies. Our galaxy, the Milky Way, contains billions of stars, and it's just one of billions of galaxies in the observable universe. Galaxies come in different shapes and sizes. Some are spiral-shaped like our own Milky Way with graceful arms of stars and gas. Others are elliptical, like giant cosmic footballs. And some galaxies have irregular shapes, often the result of collisions with other galaxies. Within galaxies, stars are constantly forming, living out their lives, and eventually dying. The death of massive stars in supernova explosions creates and scatters heavier elements throughout the galaxy. These elements become the building blocks for new stars, planets, and even life itself. Stars are born from collapsing clouds of gas and dust, but sometimes, not all the material ends up in the star. Leftover gas and dust can form a swirling disk around the young star. This disk, called a protoplanetary disk, is where planets are born. Over millions of years, particles in the protoplanetary disk collide and stick together, growing larger and larger. Small particles become pebbles, pebbles become boulders, and eventually planets are formed. Some planets, like Earth, form in what we call the habitable zone around their star. This zone is just the right distance from the star for liquid water to exist on the planet's surface, a crucial ingredient for life as we know it. For a long time, scientists believed that the expansion of the universe, which began with the Big Bang, would eventually slow down due to gravity. However, in the late 1990s, astronomers made a startling discovery. They found that the expansion of the universe is not slowing down, it's speeding up. This unexpected acceleration is thought to be caused by a mysterious force called dark energy. We don't know much about dark energy, but it seems to make up about 70% of the total energy density of the universe. Its presence has profound implications for the ultimate fate of the universe. Section 6. The Big Freeze, a cold and lonely end. One possible future for the universe, driven by dark energy, is called the Big Freeze. In this scenario, the universe will continue to expand forever. As it expands, galaxies will move farther and farther apart from each other. Over trillions of years, the gas clouds that give birth to stars will be exhausted, and new star formation will cease. Existing stars will slowly burn out, leaving behind only dim remnants like white dwarfs, neutron stars, and black holes. The universe will become a dark, cold, and lonely place, with matter and energy spread so thinly that nothing significant will ever happen again. Section 7. The Big Rip, when the universe unravels. The Big Rip is a more dramatic and violent end to the universe than the Big Freeze. This scenario is based on the idea that dark energy might be getting stronger over time. If dark energy continues to increase in strength, it could eventually overcome all other forces in the universe, including gravity, the electromagnetic force, and even the forces holding atoms together. In a Big Rip scenario, the very fabric of space-time would be ripped apart. Galaxies would be torn asunder, stars would be shredded, and even atoms themselves would be ripped to pieces. Section 8, The Big Crunch, a return to the beginning? Unlike the Big Freeze and the Big Rip, which describe an ever-expanding universe, the Big Crunch proposes a different fate. In this scenario, the expansion of the universe eventually slows down and reverses. Gravity takes over, pulling everything back together. Galaxies begin to rush towards each other, colliding and merging in a spectacular cosmic dance. The universe gets hotter and denser as it collapses in on itself. Finally, everything is compressed back into an extremely hot, dense state, similar to the conditions just before the Big Bang. Some theories suggest that a new Big Bang could follow this Big Crunch, starting the cycle of cosmic evolution all over again. Section 9. The Universe's Unanswered Questions, a Journey Without End. The universe is a vast and mysterious place, full of wonders that we are only beginning to understand. While we have learned a great deal about its origin, evolution, and possible futures, many questions remain unanswered. What exactly is dark energy, and how does it influence the fate of the universe? Are there other universes beyond our own, and is there life out there somewhere in the vastness of space? These are just a few of the questions that continue to inspire astronomers, physicists, and space enthusiasts alike. The journey to understand the universe is a journey without end, filled with endless possibilities for discovery and wonder.